Okay, I'm still not quite understanding how this parcel theory of air explains lift.
Aha. So, let us agree first of all that what I've managed to do with this parcel theory is redirect the flow downwards, correct?
Uh-huh.
So we said we were going to do that. We came up with a mechanism for doing that, which is to pretend that the air is in parcels and to grab onto it with a string.
Uh-huh.
So now we're going to use it to talk about lift. And here I have, oops, sorry about that, I have a makeshift bucket. This is a little container of water suspended from a string. Now the question is, can I hold this thing upside down without the water spilling out of it? Yes or no?
Centrifugal force maybe? I don't know.
Aha! A genius in our midst. In fact, now if I start spinning it like this,
Uh-huh.
notice that the water is not falling out, right?
Can you prove to me that there's water in there?
Okay. And here it is. There's water.
Oh yeah, okay.
Indeed. So the water is not falling out as it goes over the top of the curve, right?
Right.
Notice that? And that is because of centrifugal force. So let's talk a little bit about the bucket of water effect. Let's go to the whiteboard, erase a little bit of space for ourselves. So here's a bucket of water, right?
Uh-huh.
And it is spinning around. And there's a bit of water in it right there. And because of centrifugal force, the water is being pushed upwards, contrary to gravity, as it were.
But what does this have to do with airplanes?
We will talk about that in a minute. Let's just think about the bucket for a while.
Okay.
The water is being pushed upwards contrary to gravity, and that is keeping the water inside of the bucket.
Oh.
Now, alternatively, I can think that the string that I'm holding onto here is being pulled up, and I'm pulling down on it with my finger. As this bucket goes over the top, it is actually pulling on my hand, right? As it goes round, if I spin it fast enough, as it goes over the top, it's actually pulling upwards. I'm having to push down on it, right?
Mm-hmm.
Now, another thing about the string is that the string is very thin, so it does not transmit forces sideways. So I know the only way this thing is pulling on my hand is along the string, right? The only force is this way. If I'm grabbing it here, there's no force that way, there's no force that way. It's just either up or down, and it's actually not down because the string will collapse. So I know any force is just pulling up. This is going to be important.
Mm-hmm.
All right? So now let's apply that to the parcels of air. So I have a parcel of air, and I attach it to a string, and I constrain it to rotate around this point. Right? Now, as it rotates around this point, just like the water, it produces a force upwards because of centrifugal force. That force is now acting along this string, and it is pulling directly upwards in the direction that this thing is going, right?
Yep.
Now let's fast forward time a little bit more. This parcel of air has now proceeded to over here. It is still attached to this string. It is still pulling upwards by centrifugal force, right?
Mm-hmm.
And in which direction is this force from this parcel acting on my pivot point? This way, along the string.
Mm-hmm.
And then let's say this is where I let it go, so then off goes the little parcel, and it zooms off in this direction, never to be seen more. So it came in this way, it came out that way, and we're done with it.
Mm-hmm.
Now, I didn't tell you what mechanism it is we're going to use to make this happen. I'm imagining this fake mechanism of attaching strings to the parcels of air. Right?
Mm-hmm.
But do you see now how this produced lift?
Mm-hmm.
The lift is produced by the string that I'm holding onto and having the parcel of air pull up on that string as it goes around the bend.
I see.
Now here's another interesting thing about that. notice that I had to grab onto this parcel of air for a certain amount of time before letting it go.
Uh-huh.
During its swing, and especially as it swung more and more backwards, this force from the string was pulling not only upwards but also backwards.
Okay.
See that?
Uh-huh.
This force is called drag. Right?
Uh-huh.
And it turns out that any lift generating mechanism that we can invent that turns the flow sideways this way will produce drag as well as lift. This is not drag caused by, I don't know, inefficiencies or friction or a poorly designed airplane or this or that or the other. It's not losses. It is foundational forces that arise from any lift generating process. And this, therefore, is called induced drag. It is drag that is induced by the process of producing lift. All right?
Okay.
All right. Now, I'm going to talk about another kind of drag, which I will refer to as parasite drag. So parasite drag is the other kind of drag that impinges upon this airplane for reasons other than lift generating.
Mm-hmm.
And that is, your airplane is not is an infinitely small object, right? It's a big thing, plump, that goes through the air and warbles it around in different ways, and that produces more drag caused by the motion of any kind of body through the air. All right?
Mm-hmm.
So now we've basically linked this lift-producing mechanism to induce drag, to centrifugal force, to bending the airflow. The next thing I'm going to do is I'm going to, without any knowledge of the details of how this thing works, using just this model of how we generate lift, I'm going to be able to show you the so-called lift-drag curves of an airplane. And that is the next chapter.
Okay.